Hello students, welcome to Young Cubs. Today is the second session of the chapter Properties of Materials. As promised in the previous lecture, I will teach you how to memorize the first 20 elements of the periodic table. Okay, so come on. First, let's look at what's written in blue. We'll repeat this statement 3 times. Hi, hello, listen, BBC News on Friday night. Hi, hello, listen, BBC News on Friday night. So, the H, hi stands for hydrogen, hello, helium, listen, lithium, B, first B, beryllium, second B, boron, C is carbon. Hi, hello, listen, BBC. News, N stands for nitrogen, O stands for oxygen, F stands for fluorine, N stands for neon. Take a look at the symbols simultaneously, children. Yes. Hi, hello, listen, BBC News on Friday night. Hi, hello, listen, BBC News on Friday night. So, hi stands for hydrogen, hello, helium, listen, hi, hello, listen, lithium, hi, hello, listen, BBC, beryllium, boron, carbon, BBC News, N, nitrogen, on, oxygen, Friday night, fluorine and neon. So this is how you can remember your first 10. Next 10 is a little in Hindi. ना मांगो अली से पेप्सी सोडा कोका कोला और कीमती कार. ना मांगो अली से पेप्सी सोडा कोका कोला और कीमती कार. ना मांगो अली से पेप्सी सोडा कोका कोला और कीमती कार. Na stands for sodium. Sodium, basically the first letter is not its symbol. Sodium has got its name from sodium has got its symbol from its Latin name. So na mango, magnesium, aluminium. The first Si, say is silicon, then Pepsi P, S again is sulfur, then chlorine, argon, it's not argon, it's argon. Okay, K, Kimti is potassium, again got its name from its Latin name. It got its symbol from its Latin name. And Ca is calcium. ना मांगो अली से पेप्सी सोडा कोका कोला और कीमती कार. Okay, so how do we go about it? Hi, hello, listen, BBC News on Friday night. ना मांगो अली से पेप्सी सोडा कोका कोला और कीमती कार. Hi, hello, listen, BBC News on Friday night. ना मांगो अली से पेप्सी सोडा कोका कोला और कीमती कार. Children, if you say that 5 to 7 times repetitively, trust me, you will be able to memorize the first 20 elements very easily. Now, the first 20 elements are clear. Let's arrange them with their symbols and atomic number in this periodic table. It's a table. Okay? Okay. Here, the first one, we'll go horizontally, children. So the first one is H. What was the first one? Hi, hello, listen. So hi, hello, listen, B, see news on Friday night. How simple was that? After that, na mango Alice. So na mango Ali se Pepsi soda Coca-Cola na mango Alice Pepsi soda Coca-Cola और कीमती car. How easy was it to fill the periodic table of at least first 20 elements? Now, as I said, let's fill the periodic table with the help with the symbols as well as the atomic number. So the atomic number, smaller number, ऊपर लिखना चाहिए, बड़ों को नीचे, heavy things go down, lighter things go up. So atomic number on top of the symbol. Okay, so 1 atomic number is like the roll number. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Here. Hope this was easy. Now, children, this periodic table tells us a lot. It gives us a lot of information. Okay, so right now at least you got the information of the first 20 elements in a sequence. You got to know their atomic number and their symbols as of now. To add on to this information, this periodic table has been divided into vertical columns. Columns means look at it vertically downwards. And it also gives us horizontally. It gives us information horizontally. Yes. Okay. So if you look at the vertical columns, if you go like that, if you go about with the information like that, okay, they are known as groups. Okay, and if you look at it horizontally, okay, they are known as periods. Okay, now this also helps a lot in identifying the nature and properties of various elements. All right, so vertically they are known as groups. If you look at it horizontally like that, in a horizontal fashion, okay, going about horizontally, they are known as periods. Okay, children, looking at the atomic number, what more can you find out? The number of protons or the number of the number of electrons in an atom? Yes, the number of electrons will help you, will help you with the information of how many electrons. Rather, let me put it that way. The number of electrons will help you with the electronic configuration of a particular atom. Yeah, of a particular element. Yes, if I say, if you look at potassium, okay, what's the atomic number? 19. 19 means number of protons is equal to the number of electrons. So we know that that in the first shell only 2 can be placed. In the second shell 8. So 2 plus 8, 10. The rest 9. Okay, the third shell will have 8. So it becomes 18, and the last one will have 1. So this atomic number will also help you to find out the electronic configuration. For homework, children, I request you to make this periodic table with, with the mentioning the symbols, the atomic number, and the electronic configuration at the bottom of each element box or each element block. Yes, children. So as of now, so much of an information. All right. Now, what do these columns? Okay. Now, this periodic table apparently has been divided into metals and non-metals. Okay. Group 1, this is your group 1, and group 2 are metals. In the middle, there are group 3, group 4, group 5, depending on the number of electrons in the outer shell. Okay, so if the outer shell has 1 electron, so if you look at potassium, it has 2, 8, 8, 1. It has 1 in the outer shell. That's the reason why it has been placed in group 1. If you look at calcium, it has 2, 8, 8, 2. The last shell has 2 electrons. That's the reason why it is placed in group 2. So group 1 and group 2 are metals. Group 8, if you look at this one, this is group 8. Okay, or you can say this is this is group 8 or group 0. Let's put it as group 0. Okay, group 0. Why 0? If you look at this can also be termed as group 8 as of now. It has, why group 8? Because it has 8 electrons in its outermost shell. Okay, except for helium. Helium just has 2. It has attained its duplet state. Okay, there is no more capacity for helium to have more electrons. So 0 capacity, hence it is also known as group 0. Okay, so if you look at neon, what is the electronic configuration? First shell 2, second shell 8. Over capacity is 0, hence placed in group 0. Similarly, 2, 8, 8. 18, 0 capacity, hence it is placed in group 0. Before group 0, this group is your group 7. This is group 7. Okay, why group 7? Because it has 7 electrons in its outermost shell. Okay, let's find out how. So 2 in the first shell. Okay, then see, remember, rule number 9, atomic number 9. How many can there be in the thing? 9 minus 2, 7. Alright, here this one, this has 2 plus 8, 10, and the last shell has 7. So that's the reason why group 7. The middle one's children from group 3 onwards to group 6 is not what we will learn now in grade 8. Okay, we will learn about it when you take up science as your mainstream. But as of now, not required. First, you need to understand these 4 groups. Group 1, Group 2, group 7 and group 8. From 3 to 6 you shall do it later. Alright, and then if you see this empty space, this black space in the middle, there are a lot of elements over here as well. Okay, these elements are metals, and they are known as, they have a special name called transition metals. Many of them have two valencies. I will explain what valency is about, and then transition metals will become a little understandable for you. But as of now, we are not doing transition metals. We are not doing from group 3 to group 6 as well. Okay, like the transition metals, like this specific group has been given a name of transition metals. Each group over here, like the group 1, group 2, are they also have special names given to them. Okay, let me write the names for you. So group 1 elements, okay, group 1 elements are known as alkali metals. Group 2 elements are known as alkali earth metals. Why alkali metals? Because when these group 1 elements mix with oxygen or water, they form strong alkalis and bases. They form strong alkalis. Okay, group 2 elements are known as alkali earth metals because they also form alkalis. However, these alkalis are found in the earth, in rocks and soils. Okay, and that's the reason why the second group is known as alkali earth metals. Alright, group 7 has been named as halogens. Group 7 elements are called halogens. Why? Because they give out gases, or their gases are quite colorful. Okay? And the last one, group 0, okay, they are known as inert. They are known as or noble gases or noble elements. Alright children, so group 1 elements are known as alkali metals, group 2 elements are known as alkali earth metals, group 7 halogens, and group 8 inert or noble gases. Here we go. Okay, look at this one. Here hydrogen basically has not been placed in group 1 simply because hydrogen has its own traits somewhere. You can place it in the first group simply because its atomic number is 1 and it has 1 electron in its outermost shell. But however, it has few other things as well, due to which it has different characteristics, different properties, and hence the scientists prefer, the periodic table prefers keeping it different and separate. Okay, so hydrogen symbol H, hydrogen. On top we write the atomic number and down we write the atomic mass number. What is the formula for atomic mass number? Atomic mass number is equal to Z. What is Z? Your number of protons or atomic number plus the neutrons present in the nucleus. Okay, so the total number of particles in the nucleus, okay, is your atomic mass number, denoted by the letter A. Let's go to the second one, which is helium. Atomic number 2 and atomic number 4. Going by this, how many neutrons does it have? 4 minus 2, 2. And that's how lithium has 3 as an atomic number, 7 atomic mass number, 4, 9. So your periodic table also has room or space for not only the symbol, not only the name of the element, not only the atomic number, but atomic mass number as well. And all the more it is placed in such a fashion where it groups elements that have 1 electrons or 2 electrons or how many ever electrons in its outermost shell. So it's very easy. It's group 1 element, that means it has 1 electron in the outermost shell. Okay, on the left, it's placed on the left, and in group 1, group 1 and 2, that means they are metals. Group 7, they are non-metals. Group 8, non-reactive or inert elements. So this is how systematically this periodic table is arranged. And in the middle, there are these transition metals. Okay, all right. Now, I have a very interesting worksheet for you. Okay, let's read it. Fill in the missing information from the given atom symbols. Okay, He. Hi, hello, hair. Okay, look at here. Apparently, the atomic mass number is written on top. The number which is more is always going to be the atomic mass number. So the atomic mass number is written on top and the atomic number is written below. Okay, so looking at the atomic number 2, that means it's the second element. Yes, hi, hello, listen. So hi is hydrogen, hello is helium. So second is helium. Okay, so what's the name of the element? Helium. Okay, and what is the number of protons? 2. Number of neutrons you will have to find by this formula. What is the atomic number? The number which is more is your atomic number. The number which is more is 4. Okay, minus Z. Z is the atomic mass number is more. So atomic number is denoted by Z. So it's 2. Number of neutrons is 2. Easy. Fe. Fe is not, we have not taught you right now, but Fe is for iron. Okay, so iron is a metal. Okay, number of protons, the lesser one, 26. Yes. What is the bigger number? 56. So 56 minus 26, 30. So your number of the number of neutrons in iron is 30. Yes, let's go to the next one. Al is aluminium, Ali. So, aluminium. Number of protons 13. 27 minus 13 gives me 14. 7 minus 3, 4. 2 minus 1, 1. 14. Number of neutrons is 14. Alright, children. I want you to, you can pause the video and you can solve the rest of them right away, right now, so that you get this formula in your head and you find out the way to calculate the number of neutrons in an atom. Here, children, please tally your answers with mine. Children, I wanted to know a little more about carbon. Okay, what is the atomic number out here? Sorry. What is the atomic mass number out here? It is 12. Okay, we have carbon in, if we find carbon naturally with 13 and 6 as well, and with carbon with 14 and 6 as well. So that means the atomic number is the same, but the atomic mass number is different. If the atomic number is the same and atomic mass number is different, what is it? It is, they are, the other two are, that is carbon 13 and carbon 14. This is known as carbon 12. Okay, this one mostly found in nature is carbon 12. Okay, but if we find carbon 13, which is a 0.01% that we find carbon 13, okay, if we find carbon 13 and carbon 14 in nature, they are isotopes of carbon 12. Okay, remember the concept of isotopes? Different, same atomic number, but forms of carbon with different atomic mass numbers found. Okay, so carbon 13 and carbon 14 are isotopes of carbon. Okay, please tally your answers with mine. See the variation of B. We have one element which is Be, which is beryllium. The other one simply B, which is boron. Look at this one. Ba is barium. Br is bromine. So many Bs. Yes. Similar case with C as well. Ca, calcium. C only alone is carbon. Cl is chlorine. All right, children. Let's go for a quiz now. A small short quiz. It says protons, neutrons, and electrons worksheet. Use the symbol box. This is your symbol box. To the right, answer the following questions. S stands for sulfur. Yes, now this is all about sulfur. What is the atomic number? The number which is lesser is the atomic number, roll number. Okay, atomic number is 16. What is the atomic mass number? Children, total number of particles, protons plus electrons, 32. How many electrons? The number of protons is equal to the number of electrons. The atomic number will tell you the number of electrons. How many neutrons? So 32 minus 16 is 32. 32 minus 16 is 16. So number of neutrons also 16. And how many protons? Again 16. Yes, children. Easy. You could do this on your own if you want to practice chemistry, if you want to practice this chapter and get clarity on protons, neutrons, electrons. You could make a worksheet for yourself like that and You could go ahead, name that particular section of that. For example, I just put as phosphorus. I write the electron, I write the symbol, and then you could put these questions for yourself. Look at what number is phosphorus on. Na, mango, ali, say, with that form, that part. Okay, so you could go ahead and do that for self practice, not a compulsion. So here we are with a lot of information. So in this table, we have the symbol, the name, the atomic number, the atomic mass number. It is placed properly in group 1, group 2, group 7, group 8. Okay, so all good. Okay, one more thing just that I have to add on to is about the word valency. What does valency mean, children? The number of electrons, okay, that an atom can donate means give away, accept means that can take, or share with another atom. Okay, so and this happens only from the outermost shell. First, the outermost shell will accept, donate, or share. Okay, because the inner ones are satisfied, are in full capacity. Why should they give and take? We are happy with what we have. Okay, so the inner ones won't accept or give, and valency or rather donation or acceptance or sharing happens only when the outer shell is not in its full capacity. For example, look at lithium. What is the electronic configuration? First shell 2, second shell 1, and that's the reason why atomic number of 3. What is the capacity of the second shell? The capacity is 8. Does it have 8? No, it does not have 8. It has only 1. So now this atom feels it's better to give away that 1 electron, throw him out of the house, and attain its duplet state, or attain a shell which is in its full capacity. So it is willing to donate or willing to give away 1 electron. So willing to give away 1 electron means its valency is 1. Okay, look at say fluorine. Let's look at fluorine now. Okay, so now what is the electronic configuration of fluorine? 2 plus 8, 10. No, sorry, it's 2 plus, okay, 9 minus 2, 7. Yes, that is the outermost shell. Does it have 8 electrons? No, it needs 1 to become satisfied and become a complete satisfied atom. So it needs 1. Okay, it's willing to accept 1. So willing to accept 1 means its valency is also 1. Okay, look at carbon. Let's look at carbon. What is its electronic configuration? 2 and 4. 2 plus 4, 6. Yes. How many needed in the second shell? 8. So it says I will either give away my 4 or I am willing to accept 4 from anyone else. And that's how these methane and all these gases, the hydrocarbons are formed. So it's basically willing to give away 4 or ready to take in 4. But it says, no, I might as well share my 4. Okay, so 4 becomes its valency. Very important, children. The valency ranges from 0 to 4. Yes, either the valency can be 0, like helium, neon, argon. Nothing to give, nothing to take. Valency is 0. Either the valency could be 1, like lithium, or like fluorine, or like chlorine, or like sodium, or potassium. They have 1 in the outermost shell. All of them are willing to give away their 1 and attain stability. So their valency could be 1. Here fluorine, chlorine, bromine, iodine. Here we have bromine and iodine below. Okay, so they all have they have 7 electrons in their outermost shell. Okay, so they're willing to accept 1 electron, so their valency is also 1. So either accept or they either accept or donate 1. So their valency is 1. Similarly, here in beryllium, or here look for that matter, look at oxygen. Their outermost shell has 2 electrons. Calculate and check, children. Beryllium is first is 2, second is 2. That means 2 in the outermost shell. Cannot take in 6. Cannot take in 6. How many places will it go and accept 6 electrons? Might as well 2 is better to give away. So its valency is 2. Similar case with oxygen. Electronic configuration is 2 and 6. Ready to accept 2. Yes, children. So valency could be 2 for group 2 and this group 6. Alright, so this is how valency is calculated. Look at this one, 7. 2 in the outermost shell and 5. 2 in the inside first K shell, attain full capacity, then 5 electrons in the outermost shell, and we need 8. So 8 minus 5 is equal to 3. Valency is 3. And we just looked at carbon, how valency is 4. Yes, so valency will range from anywhere from 0 to 4. It will never be 5, 6, 7, 8. Remember, okay, valency range is only between 0 and 4. Very important, children. Now, explaining the term of valency, there's one more thing that I just realized that I could explain. So, if you look at this side of the table, the left hand side of the table, here these metals are willing to always give away 1 or 2. And here on the other side, look at these. Okay, they are willing to always accept, okay, 1, 2 or 3 electrons. So the ones that are willing to give away 1, 2 or 3 electrons, easier to give away, the ones who are more of donating nature are termed as metals. So on the left hand side, on the left hand side of the periodic table, we have the metals. On the right hand side, who are always willing to accept electrons are termed as non-metals. Got it, children? So, ideally, when we were young, we were told that metals ring, metals are shiny and all that. But chemically, that automatically is acquired if any element is willing to donate its electrons. So, as per chemistry, those elements who are willing to give away its electron, willing to give away or willing to donate, the donation ones are metals. So when they give away an electron, the number of negative charges reduce, right? Look at lithium. Lithium, number of protons will be 3. Therefore, number of electrons will be 3. But as per the electronic configuration, okay, one can be donated. And if the one is donated, okay, how many electrons? There will be only 2 electrons. How many protons? There will still be 3 protons because protons are not going anywhere. Okay, plus 3 minus 2. That means this atom will have a plus 1 charge. Lithium will have a plus 1 charge. And the moment any atom acquires a charge, it is no longer called an atom, it is called an ion, a positive ion. A positive ion is called known as cation. So, an atom is normally neutral in nature, but in case if it gives away its electron, it donates its electron, the negative charge reduces and the positive charge increases. Hence, the overall atom is no longer neutral, it acquires a positive charge. The positively charged atom will no longer be called as an atom, it will be called as an positive ion, and a special name given to positive ions is cations. On the other hand, look at fluorine. Okay. Here, this one. So, number of protons will be plus 9. Okay, number of electrons minus 9. That's the reason why it's an atom. 9 at positive 9 minus 9 nullifies, 0 charge, electrically neutral atom. Okay, but the moment it accepts 1 electron, the negative charge increases. Minus 9 minus 1 minus 10. So negative charge increases. So overall the atom does not remain neutral. It is acquired a negative charge. Okay, so no longer will it be called as an atom. It will be called as a negative ion. And a negative ion has a special name given as anion. Positively charged ion is known as cation. Negatively charged ion is called as an anion. So, oh my God, such a lot of information can be deduced or worked out from a periodic table. The symbol, the name of the element, the atomic number, the atomic mass number, the number of neutrons, metals, non-metals, what else? Whether once if it donates or accepts electrons, how many number of charges as a cation, as an anion, lot of information. Well, children, I would request you to go through this video once again, and not only once but twice or thrice, because there's a lot of information being given out in this lecture. We'll stop here. Let's call it a day. Thank you so much, children, and God bless you all.